Let's take a look at this first example. They're asking us to express this ordered pair as a table of values and also as a graph, keeping in mind that as an ordered pair, it's x comma y, input comma output. So as a table, I would put all of my x values in the x column. So my x's would be 3, 5, -1, and 4. Those are my domain values. My range would be all of the y values. I'll put those in the y column. So here are y's, the range, 0, 2, -2, and 1, keeping in mind that all of those ordered pairs are still mapped to their corresponding y's. So when we're going to graph these, I think it would make sense for us to label our points A, B, C, and D. So now let's go to the graph and we start at the origin. The origin is the point 0, 0, and on there you'll see an O on our graph. Let's start by going to point A. Relative to our origin, A is over to the right 3 and up 0. So over 1, 2, 3 and up 0. This is point A. Now let's sketch point B. When we plot point B, we're going to go to the right 5 and up 2 because B's coordinates are 5, 2. So over to the right 5, that takes us all the way to the corner, and up 2. And there we have our point B. When we plot point C, you'll see we now have negative values. Negative means we go to the left, or if it's negative in the y, we go down. This one's -1, -2. So we would go to the left 1 and down 2 units. 1 to the left and 2 down. -1, -2. Lastly, D is ordered pair 4, 1. So that takes us 4 to the right and 1 unit up. And that's in yellow, so it's hard to see. To determine whether or not this relation is a function, I can look at either the ordered pair, the table, or the graph. Sometimes visually speaking, the graph is clearest because there is no vertical line that would intersect any 4 of those coordinates. So I can also look at the table and see that every x value only goes to 1 and exactly 1 y. So if we did the same thing with this mapping and translating that to a table and a graph, our table would look like this. I would put all of my x values down, but now I want to be really careful about the y's. You notice that -8 maps to 10. So I have to put 10 down as -8's partner. -3 also maps to 10. 3 goes to 0, and 4 goes to 6. Now you might notice when I try to change this to a graph, 1, I enlarged it, but 2, looking at the y values that we had and some of the x's, I changed each tick mark so that now every one represents a unit of 2. So now if you look at the x's, it goes 2, 4, 6, 8, 10. So in between, halfway in between one whole number or one value and the next, we have our odd values. So here would be 1, here would be 3, and so on. So let's start by assigning letters to these coordinates. So if we were to do that, our A is telling us to go to the left 8, 10, up. So A would be right there. Point B is telling us to go -3, so 3 to the left and 10 up. So you'll notice that both A and B have the same y value, but they've got different x values. C is having us go 3 to the right and 0 up. So C is right there. C sits on the x-axis. And D has us go 4 to the right and 6 up. And if we wanted to identify if this is in fact a function or not, I can look at the graph and see that if I were to put a vertical line anywhere on that graph, it would not hit one of those points, more than one of those points at once. I can also see on my, if I go to the mapping, that for every x, there's only one y value that it maps to. Here's question 3. So for a problem like this, we will define our points and identify for A. We go to the right 4, down 1. Notice the increments here I chose were increments of 2, so I could fit that all in. There's A. For B, we want to go to the right 5 and up 3. And you'll notice, because those are in between my even numbers, B is right there, right in the middle of that square. C is asking me to go to the right 5 and up 2. So there's C. Lastly, D wants me to go to the right 6 and up 6, leaving us with D there. So folks, if I wanted to see if this relation was a function, I would do my vertical line, take my vertical line and trace it. I'm okay with A, but what happens when we go to B and C? It crosses at those 2 points. D's fine, but here, this would make our relation not. So for these problems, it's asking us to use the vertical line to identify if this equation or relation is a function. So I'm going to take my vertical line and see if it ever intersects it in more than one point. If it intersects that graph. And 5 looks good. 5 is a function. Now I'm taking that vertical line to 6. And I'm going to see if it hits it in more than one point. And I think we see, oh yeah, this is not a function because it intersects that graph in more than one point. 7 is a little bit strange because 7 is in fact a vertical line. So let's see. Is this vertical line going to pass the vertical line test? Absolutely not. Every point that's on that line is on top of my vertical line. So 7 does not pass the vertical line test